Welcome to BTEC Revision. In today's lesson, we're looking at permeability. By the end, we should be able to calculate the permeability and relative permeability of a material. What is permeability? Permeability measures the amount of magnetization of a material. And we can use the lowercase mu to represent permeability. And we can calculate permeability with this equation, which is equal to magnetic flux density divided by magnetic field strength. The short form is mu equals B divided by H. The units we used for magnetic flux density is Tesla, and it's T for short. And the units we used for magnetic field strength is amps per meter. So rearranging this, we can get Tesla meters per amps as the unit for permeability. And permeability also has another unit, henries per meter. H is short form for henries. Now, let's look at an example. A magnetic material has a magnetic flux density of 0.004 Tesla and a magnetic field strength of 200 amps per meter. Calculate the permeability of the material. You can start by writing down our equation. Permeability equals magnetic flux density divided by magnetic field strength. And we can plug in our value, 0.004 divided by 200. And that gives us a value of 2 times 10 to the power of minus 5. And the unit is henries per meter, H divided by N. Next, we can look at what relative permeability is. Mu R for short, and it describes how a material responds to the presence of an external magnetic field in comparison to free space. And we can calculate relative permeability with this equation, which is equal to permeability divided by the permeability of free space. The short form is mu r equals mu divided by mu naught, where mu naught is a universal constant, which is equal to 4 pi times 10 to the power of minus 7 henries per meter. Let's look at some examples of mediums with the relative permeabilities. For example, let's take vacuum, which has a relative permeability of 1. Air and wood would be close to 1, and same for aluminium. Carbon is going to have a permeability of 100. And looking at the units, permeability is going to have a unit of henries per meter, and permeability of free space also has a unit of henries per meter. So if we divide henries per meter with henries per meter, we get 1. Therefore, relative permeability is dimensionless. Now, let's look at an example. A material has a permeability of 2.5 10 to the power of minus 6 Tesla meters per amps. Calculate its relative permeability when exposed to an external magnetic field. Now, pause the video here and attempt this exam question. A material has a relative permeability of 150. Calculate the magnetic flux density when the magnetic field strength is 2.5 milliamps per meter. We can start by writing down our equations. Mu R equals mu divided by mu naught, and we also know that mu equals B divided by H. So what we can do is replace the mu in the second equation into the first, which would give us mu R equals B divided by mu naught H. And since the question is asking for magnetic flux density, can rearrange for B, and it gives us mu naught mu R H. And now we can plug in values. So mu naught is 4 pi times 10 to the power of minus 7. Mu R is 150. And H is 2.5, and it's milli, so that's times 10 to the power of minus 3. And this gives us a value of 4.71 times 10 to the power of minus 7 Teslas. And that's the end of the lesson. If you'd like to boost your grades, visit us at btechrevision.com. See you next lesson.